Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the GRI. This is their part number 29C. This is a surface mount magnetic contact, single pole double throw, and the W in the part number that we have stands for white. And here it is. There's going to be five primary components. You have the business end, the portion that you're going to connect to your wires. There's three terminals. You only use two of the three, and we'll talk about that in a moment. Then you're going to have, of course, your magnet that will either allow you to have the circuit open or closed depending on how you wire it and what you want to have happen. Okay. You're going to have a shim. One will come with each if you need to use a shim. You're going to have a cover as well, which is really nice because it will allow you to simply cover off what you're seeing there in terms of the terminals so that it looks ultimately like that. Okay. Let's take some basic dimensional properties. And by the way, the weight is about 0.08 pound, 0.08. So about 12.5 of these per pound. Overall width of the unit, about 2.5. Or length. Overall depth, I'd say, or width would be about 1/2 inch. Total projection, just heavy on 1/2 inch. Center to center of the screw holes, just in case that information is valuable to you. Looks like it's about 2 1/16 or so, maybe 2 1/8. Okay, so the magnet's going to be present or it's not going to be present. The cover, the shim, etc. The fifth component would be the screws. You'll get a total of 4 of these small little sheet metal screws. Number 6, I'd say, by 3/4 perhaps. Pan head. Now, why are there 3 terminals? Well, there's going to be, this is a single pole double throw. That's what would also be known as a Form C switch. Form C is not really, Form C is used in the builder's hardware, low voltage electrified hardware portion of what we do, but, you know, it's single pole double throw. I mean, to know that that's Form C, that's great. That's good to know that. But we'd call it single pole double throw. But the industry term, I think, is Form C. What that basically means is you'll have a common, and then you're going to have a normally open and a normally closed. So your switch is either going to be in one condition or the other when you take it out of the box. Okay. So let's start over. When you take this out of the box, you got these 2 pieces in your hands. That's its natural state. It's either going to be here or here. When you bring the 2 together, whatever its natural state is, here, then goes to here until you separate them again. Okay? So it's that easy. Its natural state is however it comes out of the bag. I don't believe we're going to consider them together to be the natural state. Which doesn't matter because depending on whether they're together or separated, you can control whether or not you're doing this open or closed. So the next component to think about is what's normally open or normally closed. The circuit is either open or the circuit is either closed. It might be difficult to put that into, our everyday use, but an open circuit means it's open in the sense that there is no continuity. The circuit is open. There's no continuity. When you close it, then you can run current through that circuit. The way I think of it is, imagine if you have a laser pointer in your hand and you've got a bank of doors. All the doors are closed. My laser pointer, I can point across all those doors and it will go continuously. If I open up one of those doors and I run my laser pointer, now I'm going to lose my laser pointer. It can't get to. So it's a funny, weird way. That's what I use to remember whether the circuit is open or closed. So depending on how you install this, do you want there to be continuity when the door or the window or whatever is such closed, let's say. So let's say that there is continuity. Let's say that there is no continuity. Let's say that you have a door and you want there to be, when the door is closed, the magnets will be together. So let's say that you want no continuity when that occurs. Because when the door opens, you want there to be an annunciator, a fancy word for a bell or a buzzer. So when you open that door, current will then flow, allowing you to power or run current through the powered annunciator. A bell. Someone opened the door, the bell goes off. Okay. Let's say that you want to be able to have a light go off, whatever the case might be. Or let's say that you want to be able to have a very common application. A restroom at a park, a public park. There are now touchpads, handicap access. You can hit a touchpad or wave at a touchpad. The door will open with an automatic operator. You'll go in. You will lock that door, okay, manually, or with a touchpad. There is a switch like this on that door that might interrupt, that might tell the controller in the system the door has been cycled, okay, until the door is opened, meaning someone exits. So the natural state of this will, when it's closed or opened, will tell that controller, the door has been cycled again, reset the system. So it can be something as simple as, a bell going off when the door is opened, all the way to resetting a controller. So let's do a little deeper dive on illustrating all of this, the difference between normally open and normally closed. Let's switch our screen view here. Okay, so let's take a little closer look at how we can illustrate this. So I have my voltmeter here, and voltmeters are really cool tools that I think everyone should own. Even if you have no need for a voltmeter, someday you're going to. Everyone has a need for a voltmeter. Your husband, your wife, your child, your grandmother, everyone does. At the very minimum, you could use it to know whether or not your car battery is producing enough voltage to start. Voltage is kind of like a value that if your car requires 10.8 volts to start and your battery is telling you have 10.7, it's not going to work at all, in fact. So just want to get this moved here. Get our parts moved here. So what you would use, so what we're going to do is we're going to test to see how this operates. And we're going to demonstrate how common sorry, it's really giving me a lot of glare here. Because it's white. Anyway, well, common is here. Then we have normally closed and normally open. Common, NC, NO. So what we would use would be impedance, or the ohms setting on this. So what we're going to do is we're going to hold one lead to our common, which is here if you recall. Well, let's just turn it on. I've got it set to ohms. And I'll set one lead to common, and I'll set it to normally closed. We get something happening there. On normally open, we get nothing happening there. Normally closed, we get an indicator. Normally open, we don't. So what we have here is obviously, let's say there's continuity, let's say there's no continuity, okay? This is how it comes out of the box. Those parts are separated, okay? Separated parts. Now, let's put the two parts together. Let's just hold them like this. Now, as we talked about earlier, the behavior should change. When I go to normally closed, I get nothing. When I go to normally open, I get continuity. Oh, sorry, you can't see that. I'm holding it too high. I've got them held together. When I go to normally closed, I get nothing. When I go to normally open, I get continuity. When I drop that magnet out, the opposite happens. Okay? And my hand is just with the black lead covering that. So that's just a neat way to understand how this actually works, in the sense of it dispels, you know, the concept of voodoo and black magic when it comes to how this stuff works. Really what it boils down to is just simply an understanding of what you want the circuit to do depending on the condition of the hardware. You can reverse that by reversing the condition of the hardware, and you can reverse that by reversing the wiring as well. So let's switch back to our standard camera view.
What Randall's doing with like the inventory on merchant tools?
Okay, so now let's just take a look at the item in our site, the GRI 29C-W. Color white will work with gaps up to 1 inch. Single pole double throw. That's worth taking a look at. Here is a pretty straightforward view of what that circuit would look like. Yeah, so, you know, this is pretty much what the circuit looks like, so that you understand one condition will give you this. And when you change the state of the hardware, meaning, so let's imagine that we're dealing with a door, and when the door is closed, the contact and the magnet, the switch is together. The magnet and the electrical portion are together. When you open the door, you change the state. You go to the opposite. So let's just say door closed, door open. That's a Form C switch. That's single pole double throw. There are others. We're going to move on now. Screw down flanges, side screw terminals, hermetically sealed. Plated contacts resist sticking or freezing. Let's take a look at the rest. Switches and magnets available separately, sure, piece parts, whatnot. Okay, so pretty simple. There's a link to the template that's here. The 29 series we're seeing here with the cover, the electrical portion, the magnet, and then the shim. (29C) single pole double throw right here. Double pole double throw is going to give you the ability to have two commons involved with a normally open or a normally closed. So you can do two things at once with that. That's cool. Closed loop and open loop is, you know, kind of the same concept of the natural state is either open or it's closed. But you don't, there would only be two terminals with these. You don't have the ability to select that in the field. If you know that your loop is always closed, you would just order that style of unit. Dimensional properties, we've kind of gone over that here. The table showing the electrical characteristics of all these items. Our 29C can handle up to a quarter amp, 250 milliamps, at a maximum rating of 175 volts DC, which in low voltage we would never see anything like that. 24 is the maximum I can think of. I have been told that there were DC hardware years ago that exceeded 24 volts, but today it would either be 12 or 24. In DC current, AC current can be, you know, 8, 12, 16, 24, things of that nature. There you go. Pretty simple and straightforward. Okay. Now, there's a link below this video here to the manufacturer's page where you can pull up not only all of the GRI products that we sell, but also a link to the website, the manufacturer's website, as well as link to their price list, which is probably a document that you wouldn't need at all. competitor cross-references here. That's handy because if you're looking to go from someone else's part number to theirs, you can do that. I don't have experience with these other manufacturers. GE Security, I would, if they're here at all. Yeah, right here, GE or Central. Those part numbers I'm somewhat familiar with. Let's wrap up this video on camera. In conclusion, I think it's a fairly simple and straightforward piece of equipment. You can buy them in any quantity. This client happened to buy 100 of them, so there are 10 bags of 10 complete sets here for our client. I have called GRI, or George Risk Industries, in the past and have asked for technical support, and the person who answers the phone transfers me to someone else, and that someone else is exceptionally helpful, exceptionally patient, making sure at the end of the conversation that you do understand the concept, because conveying electrical concepts is not easy, and I, have very little talent for retaining that information. So calling the factory, in this case George Risk Industries, and asking for, tell me what a closed loop is, and that's a technical term beyond the construct of this video, but very, very helpful. I have used contacts by other people, and can tell you that I see no reason to not use something by George Risk Industries. You got a phone number, you got a call, you got one person to get to, technical support provided, so really great. It's not a hinge where you've got 8 screws, lefty-loosey, righty-tighty, and you're done. It's not. It's a product line inherently that requires technical support at least some level, sometimes, and you can count on them for that. Any questions on the 29C and a W finish, a white finish, or any other George Risk Industries product, please feel free to reach out to us. And thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.